I will show you how exactly drawing is done on drawing sheet. Already you did it on your sketchbook and drawing sheet, but still with the help of this animation it will be helpful.
Specifications and tools using which an abstract concept can be transformed into a real-world entity. Applications of engineering drawing are varied. For example, shipping industry, manufacturing, construction, and many more. Alright, so before we actually start drawing something, let's warm up with some important concepts. So first, let's take theory of projections. The word projection means to throw forward. It is a process of plotting an object or an entity on imaginary planes. Projection has two types. First is parallel projection and second is perspective projection. Each of these in turn has further subtypes. We will focus on orthographic projections, where the projectors are parallel to each other and they intersect the projection plane at right angles. We will study orthographic projection in detail later. So let's take a look at important tools used in engineering drawing. Drawing paper, drawing board, drafter, T-square, compass.
The T-square is used in architecture particularly.
French curves, protractor, set squares, scales, pencils, erasers. Before you start drawing, always make sure that the size of drawing paper is less than the size of the drawing board. Also make sure that paper is fixed properly with drawing pins and it is smooth without any wrinkles or
pins, we use clips.
The drawing board is a plain and smooth surface used for drawing purpose. The ergonomic edge of the drawing board facilitates smooth movement of T-square. The T-square, as the name suggests, is a T-shaped drawing tool. Its straight edge slides along the width of the drawing board with the help of a stalk. It is useful in drawing straight lines and also serves as supporting edge for set squares while drawing inclined lines. As you already know, the compass is used for drawing circles and arcs. The divider is a little different, with both legs made of steel and is used for transferring distances. Another interesting tool is French curves. They are used to draw irregular curves such as ellipses, parabolas, hyperbolas, and the like. The drafter is a very useful tool for drawing parallel lines at any given inclination. It has a scale as well as protractor inbuilt. Looks like a robot, isn't it? Protractor is used to measure and lay out angles. Another tool is set squares, also known as triangles. They come in flavors of 30, 60, 90 degrees and 45, 45, 90 degrees. Alright, so we are all set to now begin understanding basic concepts of drawing, which we will cover in the next presentation. Hello, and welcome back. Now that we have seen all the
various drawing techniques,
it's time to understand the drawing techniques. Let's start with drawing scales. Drawing scales allow us to draw any object to the required size on the paper. For small objects, for example a mobile phone, a drawing of prototype can be drawn to the same size as the original, that is 1:1 on the drawing paper. Such drawings are known as full-size drawings. However, generally the prototype is either too large, for example the Eiffel Tower, or too small, for example a micro-scale motor, and we will have to scale down or scale up the dimensions of the prototype in order to represent it on the drawing paper. The representative factor Rf is a ratio of drawing dimension to the actual dimension.
This you are saying in class, RF. How do you listen for that?
Then the drawing is enlarged. And if it is less than 1, then the drawing is a reduced view of the same object. So, we are all set to move on for preparing our drawing paper. We have to put together layout on paper, including margin, border, and other entities. The engineering drawings may also contain letters used for dimensioning, writing instructions, notes, titles, labels, etc. The term used for engineering drawing text is lettering. Next element is line. Lines are the predominant and the fundamental drawing element in every drawing. Various types of lines are used to represent different entities, like visible lines are used for drawing outlines of visible edges, and surface lines which represent the objects. These are drawn in bold, dark, and continuous lines. Hidden lines are shown with medium thin lines consisting of short dashes and are used to represent invisible edges and surface boundaries. Center lines are thin lines drawn with alternate long dashes and dots and are used for representing symmetrical objects. Then there are dimension lines, extension lines, and cutting plane lines. Well, now it's time to give exact dimensions to our drawings. Dimensioning plays a very important role while drawing. There are many types of dimensioning, such as horizontal dimensioning, vertical dimensioning, aligned dimensioning, chain or continuous dimensioning, parallel dimensioning, diameter dimensioning for circles, radius dimensioning for arcs, angular dimensioning for angles. And that's it. So with this, we have covered all the necessary fundamentals of engineering.
Okay, so these dimensions, types of lines, all those things we have studied in class, theory class, and particularly first drawing sheet you are drawing types of lines, application of lines, and how to show dimensions. Every time I am giving stress on dimensions, how to show dimensions. Every time I suggest you to show dimensions properly, because this is very important part of engineering career. As being engineering student, so you have to follow some standards. So those standards are shown in this particular animation. Now, how to divide line, how to divide angle. Those who are having still doubt, with the help of this particularly you will find.
Time for briefing that. In the last session, we were exposed to the fundamentals of drawings, the concepts and types of drawings. Let's now go over some important geometrical constructions. But first, what is a geometrical construction anyway? Geometrical construction is a process of drawing different shapes and figures and manipulating them with the use of drawing tools. Okay, the study of geometrical construction starts by understanding lines and angles. Lines have different types, such as straight lines, parallel lines, and perpendicular lines. Angles also come in various flavors like right angle, an acute angle, and an obtuse angle. In this presentation, we will understand how to divide line, how to draw a perpendicular line, then dividing an angle in n equal parts. Sounds a lot and difficult? Let me tell you, it is not. All right. Now, we will take a look at how to divide line into 7 equal parts. First, consider line AB of any length and draw line AC, making an angle of less than 30 degrees with AB. With the help of dividers, mark 7 equal parts of any suitable length on line AC and mark them by points 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, and 7 dash. Join point 7 dash with point B of the line A and draw.
So this is one of the problems that we are solving, particularly drawing sheet. 85 mm line is divided into 8 parts. Procedure you may say we can show angle above that line or angle below that line. Only thing is that you have to take angle less than 30 degree or acute angle. We will say it's acute angle. Okay, procedure remains same.
Lines parallel to 7 dash.
How to join line, that is also important. Drafter will be helpful for you people.
4, 3, 2 and 1 respectively.
7 will be last B.
The line A has been divided into 7 equal parts. It was easy, isn't it? Now let's understand how to draw a perpendicular line to another line AB from a given point P which is not on line AB. Using compass,
This is somewhat extra knowledge now.
arc of radius say R1 from point P which cuts the line AB at points X and Y. Now taking X and Y as centers and some radius R2, draw arcs cutting each other at point Q above line AB. Let's join points Q and P and extend that line till it cuts line AB. What do you see? Since triangles PHY and QHY are isosceles and their base is common, the line PQ must be perpendicular to line AB. That was also easy, isn't it? Now let's crack something tough. For that, we will divide a right angle CAB in 3 equal parts. Let's take A as center and with an arbitrary radius R, draw an arc to cut the sides AC and AB at points P and Q respectively. Then, with P and Q as centers, draw arcs to cut the arc PQ at M and N respectively. Now join AM and extend it till it is long enough. Similarly, join line AN and extend it long enough. Their intersection points with outer arcs are M dash and N dash. So this is how we have created lines AM dash and AN dash that divide the angle CAB into 3 equal parts. If you measure them, then they will be 30 degrees each. So friends, in this session we will learn how to divide a line in equal parts, how to draw perpendicular line to a line, and divide an angle in equal parts.
This is also important, how to divide line, how to divide this arc, how to bisect angle, all those things. 6 marks questions are possible in examination. Now construction of polygon. If some students are having doubt how to construct polygon, or the different types of polygons are there.
Hi, welcome. In this session, we will study various methods to construct different polygons. First, we will construct a regular heptagon with side length of 25 mm. We will use inscribed circle method to construct this heptagon. First, draw a line AC of 25 mm.
Inscribe a superscribe. Don't get confused in examination, very important.
Then, at point P, we will draw a line AC perpendicular to AC and its length is same as AC. Then, draw line AC. Now, with center P and radius AB, draw a quadrant BC. Then, draw the perpendicular bisector of line AB, which intersects the line AC at point 4 and RAB at point 6. After that, bisect the line 4 stages of 8.5. Measure the distance of line 5 and transfer it above to obtain point 7. Draw a circle using point 7 as a center and radius of E7. Using compass, make 7 equal parts of the circle with side length as AC. So here is our heptagon. Thus, we can draw different kinds of polygons by using 6 and radius as A6. Now let's draw a pentagon of side length equal to 30 mm. First we draw a line AB equal to 30 mm. Draw a circle with center as A and radius as AB. Similarly, draw one more circle with center as B and the radius as AB, cutting the circle 1 and C and D. Next, draw an arc with center as B and radius as AB. The arc cuts the circle 1 and circle C at E and F respectively. Then, draw a perpendicular bisector at A, which cuts the arc EF at point G. Draw line EG long enough to cut the circle at point G. Similarly, line FG is extended to cut the circle 1 at point R. After that, with E and R as center and AB as radius, draw two arcs intersecting each other at point Q. Finally, let's draw lines connecting these points to complete the pentagon. Fine, let's study a simple method for constructing a regular octagon. The method involves inscribing a regular octagon in a given square. Consider the given square ABC with side length equal to 50 mm. Now we draw the lines AC and BC intersecting each other at O. Then with A as center and AO as radius, draw an arc cutting edges AB and AC at point 2 and 7 respectively. Similarly, with centers as B, C and D and radius as AO, draw arcs to obtain remaining points. At last, we join the points 2, 3, 4, 5, 6, 7 and 8, 1, thus completing the octagon. So friends, I am sure that you are now ready to draw different types of polygons in engineering drawing.
There are n number of methods to draw these polygons. Whatever methods you have tried or whatever methods I have taught you in class, accordingly you will be solving the problems in examination. Don't get confused. Take your own time because 6 marks will be sure for this either pentagon, hexagon, octagon, heptagon or any kind of polygon. Method, construction line should be very faint, polygon should be dark. Every time I used to tell you the construction line should be very faint to be drawn with the help of 2H pencil and other things with the help of H pencil. Okay. Now hexagon, similar method is there, drawing hexagon. Now we will come to the theory of projection, that is projection of points.
Hello, today I will take you through theory of projections. The projection is a process of creating an image of the object on the paper as it appears when observed in a particular
vertical plane, horizontal plane and object.
Of an object is represented as a combination of elements, points, lines and planes. Using these elements as tools of drawing, we can project an outline of the object on paper. We will use orthographic projection where lines of sight are parallel to each other. These lines emerge from the corner points of the object and strike the projection plane. The image formed of the projection plane is known as the projection. The lines of sight are also known as the projectors. The size and the shape of the projection depends on the angle at which the object is being viewed.
See, object is placed above HP and in front of VP. Two planes are there, vertical plane and horizontal plane. So accordingly object is kept and observer is observing the object from this direction. So whatever rays are coming through his eyes are falling down at 90 degree perpendicular. That's why ortho position is nothing but 90 degree position or perpendicular position. So the image of that particular object is getting developed in front view on which plane? Vertical plane. At the same time, top view image is getting developed on the horizontal plane, but as we know, HP is to be rotated 90 degree clockwise. That's why the top view goes below XY. Front view above XY, that is on vertical plane, and top view below XY, that is on HP. So accordingly, it is shown.
And the distance between the object and the viewer. The projectors are perpendicular to the plane of projection. This type is known as orthogonal projection, which is prominently used in engineering drawing as they show true size proportions and shape of the objects. Planes of projection are mutually perpendicular planes known as principal or reference planes. One of them is the vertical plane VP and another one is horizontal plane HP. The intersecting line XY is the reference line. These create four quadrants named as first, second, third and fourth in anti-clockwise direction. There is one more plane known as auxiliary vertical plane AVP or profile plane PP. We use AVP when the view is from the left side or the right side of the object. Alright, now consider the object in the first quadrant. Looking at it from the front side, the image is formed on the VP and is known as front view or elevation. And if we look at it from the top, then the image formed on the HP is known as top view or plan. As the object is in the first quadrant, the projection obtained is the first angle projection. Similarly, if object is situated in the third quadrant, then projection is known as third angle projection. In the first angle projection, the object lies above HP and in front of VP. The projection of the object is like a mirror image. For the third angle projection, the object lies below the HP and behind VP, and plane of projection is assumed to be transparent, lies between the observer and the object. So the line of sight passes through the plane, thus forming an image of the object. So with these fundamentals of projection, we are ready to delve deeper into engineering drawing.
So front view, top view is clear now, vertical plane, horizontal plane, how the image is developed. Now projection of points that yesterday I have covered.
Hi friends, let's start with actual construction of orthogonal projections of points, lines and planes. First, we study the projection of simplest geometrical element as a point. So, let's start with an example. Here, a point object A is located in the first quadrant at the height of each unit above HP and distance of B units.
All four quadrants carefully seen so that everything will be clear.
At the point in the direction of the arrow, the front view will be a point A dash on BC and its top view will be A on HP, obtained by projectors drawn from the given point A. So, let's draw this projection onto a paper considering the HP is rotated in the clockwise direction by 90 degrees so that it becomes coplanar with the VP. For this, draw a horizontal reference line XY. Mark the point C anywhere on line XY. From point C, mark a point A dash at the distance of each unit above line XY and point A at the distance B units below line XY in line with A dash. Here, A and A dash represent the images of the object on VP and HP respectively, and the line joining A and A dash
pillar SP and behind VP.
behind the VP. Then the front view point A will be a point A dash on VP and its top view will be a point A on HP. So friends, now we have seen the visualization of the point. Let's see its construction. We'll repeat the step of drawing a horizontal reference line XY. Then mark a point C anywhere on the line XY. From point C, mark a point A dash at a distance of 8 units below line XY and point A at a distance of D units above line XY. The point A and C dash represent the images of the object on VP and HP respectively. The line joining AE dash is the projector line and is perpendicular to the reference line XY. Observe, its front view will be lying below XY and top view will be above XY. Now, look at the screen carefully. This is a special case in which point object R is lying within the vertical plane of the projection VP and above HP. Its front view R will be coincident with the point object itself and will be located above the reference line XY. Its top view R dash lies on the reference line XY. Similarly, if a point say A is lying within the horizontal plane of projection in front of VP, observe its top view A dash and front view A. So friends, now you have got acquainted with the concept of projection of a point in the first and third quadrant. And in the next session, we continue similar discussion.
So similar type of things are there for second and fourth quadrant as well as combination of two quadrants also. That 6-7 problems we have solved in class. Now with the help of one animation, ortho projection, I will explain, then we will stop. So this is one object, three-dimensional object is there, and its front view, top view and side view, three views are drawn. Now here, whatever color portion is there, according to that the changes are taking place in front view, side view, top view. If I move the cursor, now see the cursor is at this particular position, that's why the front view, top view and side view are shown in this particular 2D diagram, front view, side view, top view. The colors particularly, whatever portion is there. Now if I keep cursor over here, see accordingly the diagram is getting okay. Now this particular reef portion, every time whenever I talk to this particular observation, I told you the reef, it is seen as one inclined line in one of the view and in other two views width, particularly width is seen. So in the side view as well as top view, thickness or width is shown. Whereas in the front view only inclined line is there. Okay, because in top view and side view only the width is possible to see. That's why the thickness and all those things. And the hidden line or dotted lines are shown for the part which is not directly seen. See, particularly here also, accordingly the changes are shown. So front view, side view. Now here, front view is from this direction. Front view is from this direction. That's why side view is considered from right side. Side view is considered from right